Assalamualaikum and salam sejahtera. My name is Eirdina binti SARIF and I am from class D CE today. Today I will be presenting Izod impact test. The objective is to find the impact resistance of mild steel cast iron, and the apparatuses that we will be using today is the impact test machine. Step 1. Select the Izod test specimen. Today, the first specimen we'll be using is cast iron. The length is 74.5, the breadth B is 9.42, depth D is 9.36, and the depth notch is 5.1. Step 2. Test the friction loss of the conductor by using this pointed to 164 joules, and then the pendulum is released by operating the lever and without keeping the specimen. So the loss of energy due to friction that we got is 2 joules. And then step 3, the Izod test specimen as per Indian standard is IS 3766-1977 is placed into position like this. Okay, and this is the test piece, which is the cast iron, and this is the striking height. Between the cast iron is the support, and then looking at this angle is the tip striker. The direction of impact and angle between the underside of the striker are facing the test piece. And then the radius of the curvature is of striking edge. Step 4. The pendulum is released and the hammer strikes again the specimen and breaks it and swings further than the observation noted down, as you can see. And then the total loss of energy during the transit hammer is ET equals to 5 joule, and then the engineer failure for specimen ET minus EF equals to 3 joule. This is trial 1. So the observation that we got for trial 1 is that the initial energy for the hammer is 164 joule. The average loss of energy due to friction EF is 2 joule. The total loss of energy ET during transit of hammer is 5 joule, and the energy failure for specimen KU impact value equals to ET minus EF equals to 3 joule. Step 3 for trial 2, the cast iron length is 75, breadth B is 9.3, depth D is 9.4, depth of notch D is 4.2. Doing the same method as the first trial, we insert the cast iron into the machine. Now trial 2, step 4. Repeat, the total of energy during transit of hammer is 80 joule, and the energy failure of specimen ET minus EF is 6 joule. This is the observation that we got for trial 2. Initial energy of the hammer is 164 joule, and the average loss due to friction is EF equals to 2 joule, and the loss of total energy ET during transit of hammer is 8 joule, and the energy for failure of specimen is KU impact value is ET minus EF equals to 6 joule. So starting again with trial 3, repeat step 3, length is 75.9, breadth B is 9.6, depth D is 9.92, depth of notch D is 5. Still using the same specimen, cast iron. Trial 3, step 4, repeat. Total loss of energy during transit of hammer is ET equal to 7 joule, and energy for failure specimen is ET minus EF equals to 5 joule. So this is the observation for all of the trials. Trial 1, the loss of energy due to friction is 2, the loss of energy ET during transit hammer is 5, the energy failure of the specimen KU is 3, and then trial 2 is loss of energy due to friction EF is 2, the total energy during transit hammer is 5, and the energy failure of specimen is 6. Trial 3 is the same. 2, the total loss of energy is 7, and then the energy failure of specimen is 5. Okay, now we'll be repeating the Izod impact test but with a different specimen. We'll be using the mild steel. The initial length is 75.8, breadth B is 9.5, depth D is 9.4, and depth of notch D is 5. Using the same method as the first Izod impact test, using the cast iron, we are repeating it, and then the loss of energy due to friction that we got is 2 joule. using this same step as the first trial for trial 1, and then trial 1 step 4, the same thing. The test was not broken by the striking energy of the testing machine, so the impact value is obtained in different from the so this is the observation. Initial energy of hammer is 164 joule. Average loss of energy due to friction AF is 2 joule. Total loss of energy during transit hammer is indefinite because the specimen did not break in half. Energy of the failure of the specimen KU is indefinite. So, to conclude, my steel is harder than cast iron. So, repeating it again for trial 2, the length will be 76.2, breadth B is 9.6, depth D is 9.23, and depth D notch is 5. Repeating again for trial 2. Trial 2 is a success. Total loss of energy during transit is 48 joule. Total energy loss for failure of specimen is 46 joule. This is the observation for trial 2. Initial energy of the hammer is 164 joule. Average loss of energy due to friction is 2 joules. Total loss of energy during transit of hammer is 48 joule. Energy failure of specimen and impact is 46 joule. Now repeating for trial 3, using the same exact specimen, mild steel, the length will be 75.7, the breadth B will be 9.54, and then the depth D will be 9.6. Depth of notch D is 4. Repeating again for trial 3. Total loss of energy during transit hammer, ET is 44 joule, and then energy for failure specimen is ET minus EF equals to 42 joule. This is the observation. Trial 1, loss of energy due to friction is 2. Total loss of energy during transit is indefinite. Energy failure specimen for KU is indefinite. Trial 2, loss of energy due to 2. Loss of total energy during transit of hammer is 48. Energy failure of specimen is 46. Trial 3 is the same, 2. And the total loss of energy is 44. And the impact value of a failure of specimen is 42. And then the average failure of the specimen is 44.00 joule. That is all for my test.